So actually, I don't want to do it that way. I'm going to open this. If you want a copy of these digital flashcards, I think the easiest way would be to bring a zip drive, and you can just copy these directly. I'll plug it into my computer and copy it over. What's that? Put it on Canvas. I'm trying to think of how to put it on Canvas. So I'm going to open this up in Photos. And I'm just going to scroll through these. So this is our first one. This is y equals sine of x. The derivative of this is what? There you go, cosine of x. Next one, we have y equals cosine of x. The derivative is? Negative sine of x. Negative sine. Look how cool these digital flashcards are. Negative sine of x. Next one, tangent of x. Secant squared of x. Secant squared of x. Good job. Next one, we have cotangent of x. Negative cosecant squared of x. Yeah, negative cosecant squared of x. Nice. Good work. Ladies, welcome. Next one, what is the derivative of cosecant of x? Negative cosecant of x, cotangent. Yeah, negative cosecant of x, times cotangent of x. Good job. Next one, the derivative of secant of x. Secant of x times tangent of x. Yep, secant of x times tangent of x. And then we have some limits. These are not derivatives. These are just limits in general. I have the limit as x approaches 0 of sine of x over x. 1. The limit as x approaches infinity of sine of x over x. 0. The limit as x approaches infinity of cosine of x over x. 0. 0. Yep, there you go. Those are our digital flashcards. Now, as we continue to add to these flashcards, I will do that during whenever I can, my prep period or whatever. And so we'll have an ongoing development of our flashcards throughout this course for the major ideas that we need to hold on to. Now, there are certainly for some of you, like for example, the trig identities. If there's some trig identities that you don't have memorized, you might want to add those to your flashcards. For example, like the trig identity. I did not add these to our flashcards because this was more of a secondary math 3 idea. But if you want to add these, if you do not have these memorized, I do want you to add them to your own personal flashcards. You should know the Pythagorean identity. What is the Pythagorean identity? Nice. So we have cosine squared of x plus sine squared of x. That equals 1. Nice. That squared looks awful. You should also have that, it's called the quotient identity for tangent of x. What's the quotient identity for tangent? Sine of x over cosine of x. Yeah, that would be our sine of x over cosine of x. You should also have all the reciprocal properties memorized as well. The reciprocal property for tangent of x is what? Yeah, so that would be the reciprocal property for that would be 1 over, yeah. That would be 1 over cotangent of x. Yep. What about the reciprocal property for sine of x? 1 over cosine of x. Yep. What about the reciprocal property for cosine? Oh, sorry, I did it wrong. Yeah. Thank you. Let's see. What should it be? Cosecant of x. Yep. What is the reciprocal property for cosine of x? 1 over secant of x. What am I missing? I think that's basically all of the identities. So yeah, if you don't have those memorized, make them into flashcards and add those to your personal flashcards. So the last time, what was the big idea last time for 4.1? Yeah, it was the chain rule. And in fact, before we talk about the chain rule, actually let's just jump into the idea. All right, the assignment that is due today, what do I call this? 4.2. Yeah, this is 4.2 is due tonight. And 4.2 is more chain rule. More chain rule. Now the chain rule again is a way of taking the derivative as a shortcut. Remember, all of this comes, all of the different shortcuts that we learn, they all come from this concept of the limit as h approaches 0 of f of x plus h minus f of x over h. And patterns were identified from using this limit rule. And now we have shortcuts. So almost all of calculus is teaching you the shortcuts, which I think is sort of interesting when it really all boils down to this one equation here. So one of the shortcuts that we learned was called, the product rule. And the product rule says, it tells us the shortcut of how to take the derivative of some function when the function is made up of two functions or the product of two functions. So what's the shortcut for this? Yeah. I'm just writing it differently, but yeah, you have it right. Tate, good job. Nice. We also have what is called the quotient rule. And the quotient rule is the shortcut for how to take the derivative when we have a function made up of the quotient of two functions, like f of x over g of x. What's this rule? Nice. Low to high minus high to low over low low. It's fun to even say. So low d high, the derivative of high, which would be f prime of x. Low to high minus high d low, the derivative of low, over low low or low squared. Okay. And then we learned this really cool one called the chain rule. Oops. So this one is the, I labeled this one the product rule, and then I didn't do that for the quotient rule. So let's just move that down a little bit. The quotient rule. And then the last one that we learned was the chain rule. So I have h of x, and that equals f of g of x. So the derivative of this would be what?
F prime of g of x times the prime of g prime of x.
Nice, good. There you go. So we take the derivative of the outside function times the derivative of the inside function. Now, what if we have a combination of like a couple of these? Like what if you have something, so let's do some combos. What about combinations? Like what if I had something like this? I have f, let's say that we have a function of y equals f of x times g of h of x. What kind of combination do you see here?
It's a product and a chain rule combination.
It's, yeah, we're dealing with the product and the chain rule together. So the question then is, if we want to take the derivative of this, how would we do it?
Well, it would be f of x.
Right, f of x. Oops, let me write this a little nicer. f of x, okay,
f of x times g prime of h of x times h of x, or prime of h of x, sorry, plus g h of x times the prime of f, f prime x.
nice, good job. Cool. Yeah, I think that's really interesting. I never thought of this and, from, a holistic point of view with calculus, but the majority of a calculus class is teaching you the shortcuts. I think that's really interesting. All right, let's look at another. What if I have something like this? Y equals f of g of x over, I don't know, j of x. Do you see a combination with this one?
Yes.
Yeah, we have the quotient rule and the chain rule together. How in the world would we do this one? How would we do the derivative of this? Tate, j of x.
F prime of g of x times g prime minus g of x j prime of x of jx squared.
Yeah. Yeah. So anyway, that's the direction we're going. We're going into some problems where where we have to deal with combinations. So this is more of, how you think when you do the problems, trying to combine some of these together. All right, what about, yeah, let's do some problems. I want to find the derivative. Thomas, you're done with all three? Nice. No, in fact, I'm assuming, unless I give you multiple choice, I'm going to assume that this is a free response problem. And so you would just stop. Okay, now are you finished? All right, Keno, what'd you get for the first one?
So I got 2 times the quantity 2x plus 3, and then like multiply by 2.
Nice. Yep, just stop there. Yep, I'm good with that. Bentley, did you get the next one?
Yes,
Okay,
so y prime is equal to 4 times 3x squared plus 5x cubed times 3x plus 5.
all right, 3x plus 5. Does everybody agree with that? I think there's a problem with this one.
Yeah,
Bentley, what should that be?
that should be 6.
Yeah. That should be 6x plus 5. Nice. Gaia, do you have the next one? Do you know how to do it? So we're going to do what's called, it looks to me like the chain rule because I see a function inside of another function. So normally I would just have on the outside, I have y equals sine of u. This is just an angle. And in the inside, we have, in the inside of our function here, we have this x squared plus 2. So the chain rule, if we understand the chain rule correctly, what we're doing is we're taking if we have a function where that's nested inside of another function, then I'm going to take the derivative of the outside function, that would give me this piece here, times the derivative of the inside function. So Gaia, do you remember what the derivative of sine of u is? Oh, it's just cosine of u. Yeah. And it was never u, it was x squared plus 2. So I'll just write that in. So I have y prime equals cosine of x squared plus 2. So what we just did was we took the derivative of the outside function. Right, Gaia? Now we still have to take the derivative of the inside function. So what's the derivative of this piece here? Yeah, it's just 2x. Yep, and you're done. There you go. Now let's not lose track of what the whole point of a derivative is. Ethan, what's the point of a derivative? It's to what? Yep, yeah, it's to find the instantaneous rate of change for any value of x. Yep. So sometimes we get tied up in all the rules and we lose track of what the whole point of this is. The whole point is to give us that, when we take the derivative, it tells us the instantaneous rate of change of our function for any value of x that we plug into here. Okay, so let's go ahead and let's do another couple of problems. So let me just move over here. Y equals cosine of 4x cubed plus 8x. Y equals tangent of 7x squared minus 4x. Y equals secant squared of 2x squared plus 5x. Oh, that one looks scary. Winnie, do you have the first one? Times what, I'm sorry? Nice, yeah, good job. Is that what everybody else got?
Yep.
Okay. Nathaniel, do you have the next one?
Yeah, I got secant squared of squared minus 2x.
Yeah. Agreed? Tate, do you have the last one?
Not exactly, but,
Do you see the chain rule twice?
that's not cheap. Mine's
Do you see the chain rule twice here? Do you see a function inside of a function? Do you see a function inside of a function inside of a function? Because we could rewrite this, Tate. We could rewrite this as y equals secant of 2x squared plus 5x all squared. So our outside function is what?
x squared.
Yeah. The inside function is secant of maybe q. And then our inside function is,
2x squared plus 5x.
yeah. So it looks like we have to do the chain rule twice. So what's the first part?
2 of 2x squared plus 5x.
Okay, I agree with your first step. This is where it's going to get ugly. Isn't the derivative of secant of x, isn't that secant of x times tangent of x?
Yeah,
So if the derivative, if I have secant of x and the derivative of that is secant of x times tangent of x. It's gonna get messy. It's gonna get messy. Yeah, it's gonna get really long. It's gonna get long. All right, so we just took, where was I? Okay, so that would be secant of 2x squared plus 5x times tangent of 2x squared plus 5x. Would you agree with that, Tate? Okay,
by 4x.
times 4x plus 5. Yeah, just got a little bit long. Yes.
I was wondering if you could, like, at the beginning, if you could separate it into like the product rule.
Can we separate it into the product rule? So I see, like this. You want to rewrite it like this. Secant of 2x squared plus 5x
Yeah.
times secant of 2x squared plus 5x. Now, I'm not convinced it's going to look the same, but you could do some type of algebraic manipulation to get the same answer. But yes, you could do that. You absolutely could do that, and then just do the product rule. In fact, what would this be using the product rule? Gaia. No, I'm sorry, Kena.
Okay, well, I'm not sure if this is right, but I got secant of 2x squared plus 5x, and then tangent of 2x squared plus 5x. Times secant of.
Wait.
Sorry.
Okay, so what, now I caught up. Now times what?
And then times secant of 2x squared plus 5x times 4x plus 5, and then you add it again. So you just like repeat that. So you do plus all of that.
Multiply by 2.
I guess, yeah.
So this, yeah, right, because it's going to be plus the same thing, right? So secant squared, so you took the derivative so if you're looking at this piece here, that's your f of x. So we're going to keep that one that one the same. And then you took the derivative of this, we're just missing the inside function, right?
Well, the force is fine.
Yeah, so that would be our, let's move this aside. I don't know if you said it, maybe I missed it.
I'll put it at the end.
Okay, either way, yeah, you're multiplying, so the order doesn't matter, right? I want to make sure that we understand it's together. That's the only reason I'm putting it in here. So you took the derivative of the outside function, which is this piece here, times the derivative of the inside function, which is going to be this piece here. And now times just this function, right? Oh, sorry, this function. So what we did, if it helps to rewrite it like this, y equals f of x times g of x. The first thing that you did is you took the derivative of the first one, right? Times the second function. And what's the other piece?
And then plus derivative of the second function times the third function.
Yeah. And somebody else said, well, if you're adding, these are going to be the same because both of these are the same. And so somebody had a shortcut. What's the shortcut for when we add the same quantity?
Multiply by 2.
Yeah, we just multiply by 2. So we could just take this and multiply it by 2 and we're good. Wonder how close that looks to what we did up here. Are they the same? Yeah, different order, but the same. Yep. So, Kana, the answer is yes, you can. So what I'm going to do, actually, I did have another problem for you using a mixture of the two, and we did that anyway, right? We did the chain rule and the product rule. I wanted to do a mixture of at least one of them, and through Kana's help, we did it anyway. So since the main idea today is the same as the last one, where it was more of the chain rule, where we take the derivative of the outside function times the derivative of the inside function, I want to use the remainder of class working on 4.2, either individually or in groups. It is up to you. If you'll come up and grab a computer, I also have calculators over here. Let's go ahead and get to work on 4.2.
Yay.